Hi! So this is my first video and I'd like to start off with a topic in physics HL that many of you find confusing, A.1 Kinematics. So, what is kinematics? Well, kinematics is the study of motion without considering the cause of motion. It's basically just how objects move. So think of a car, for instance. How a car moves is not what kinematics is, but the actual motion of the car, how fast it goes, that's kinematics. Why do we care? Well, we'll get more into this later, but it's basically just really important to understand physics that is harder. It explains why we walk, or not why we walk, more so what we do when we walk, what we do when we drive, and how we play sports. So, yeah, let's dive into it. So, let's start off with the basics of kinematics. So displacement is basically the change in position, right? So if I'm starting from a tree and I walk 5 meters from that tree, then my displacement is 5 meters. But if I walk 5 meters from that tree and then I walk back to the tree, my position has not changed. So that means that my displacement is 0. Here's another example. If you move your desk from where it is right now to the door, then your desk has been displaced by a certain amount. So that's basically just distance, but as a vector quantity, meaning that it basically has a direction. Velocity is the rate of change of displacement. So velocity just means speed in a direction. So, for instance, if I move 5 meters away from that tree I was talking about earlier in 2 minutes, then my velocity is 2.5 meters per second. Acceleration is the rate of change of the velocity. So it's the rate of change off the rate of change of displacement, right? So if a car is speeding up, so when you press that accelerator, the car gets a little bit faster than it was before. So there's a change in velocity, right? So that's what acceleration is. And time is the duration of an event. So we're going to change this definition a little bit later when we get to 8.5. But for now, you just need to know time is how long something takes to happen, right? So that's the basics of display of kinematics. If you understand this, you've already understood most of 8.1. So, this is what I was talking about earlier when comparing speed with velocity, distance with displacement. So, scalar quantities are things that have magnitude only. A magnitude is a fixed value. It's like 1, 7, 9, just a number, a positive number. So, things that are scalar are speed, temperature, and mass. For instance, speed, you can't really be going negative 100 miles per hour, right? You can only go 100 miles per hour if it's speed. Temperature, you might be thinking, this guy's wrong here. He said that temperature is a scalar quantity. Well, that's true. Even though you can have negative 25 degrees Celsius, keep in mind the SI unit of temperature is Kelvin. Kelvin has an absolute zero, meaning that the lowest it can be is zero. It can't be negative 100 Kelvin, it can't be negative 2 Kelvin. The lowest it can go is zero. That's the same with mass. So all of these are scalar quantities. So if you were thinking of a scalar right now, you want an example, just think about the temperature in your room. What's the temperature in your room? Well, assuming it's room temperature, it's probably around 23 degrees Celsius, which is a scalar. Now, vector quantities have magnitude and direction. So think of direction as left or right, right? So you see these two cars here. Say one is moving forward and the other, even though it's tilted this way, is reversing backwards, right? So what does this mean? This car on the right is going forward, so it has a speed and a positive direction. This car, even though it's going at the same speed, is moving backward. So it's going back, the direction is opposite. So even though these two cars would have the same velocity, they'd have a different, at same speed, they'd have a different velocity because the direction's different. So now I'd like you to take a moment and think of a scalar quantity and a vector quantity of your own. It doesn't have to be physics related, just think of one. So now let's get into motion in one dimension. So motion in one dimension literally just means motion across a straight line. If you remember from math, one dimension literally just means one line, right? Either a straight vertical, a straight horizontal, or a straight diagonal line. No, wait, a diagonal doesn't work. I lied, I'm sorry. A straight horizontal or a straight vertical line. So in uniform motion, that means we have no acceleration whatsoever. Something is going at constant velocity. So a car that's going at the speed limit and staying at the speed limit has zero acceleration. That's an example of uniform motion. So when we have uniform motion, we have something really, really cool. We can relate these displacement, velocity, and acceleration and time variables together. And we can also draw them on graphs quite easily. So this is what kinematics is, drawing these variables on graphs and relating them with equations. The graphs that we'll be using are called displacement time graphs and velocity time graphs. So a displacement time graph is what you can see here, the position with the time, the blue graph on the left. So this basically shows us what the position of the car or the object is at a certain point in time. Now, the slope of this graph, meaning the gradient, if we drew a straight line here, would be what we call the velocity. Now, the velocity time graph is the one just to the right of that. So just to the right of that, we can see how the speed or the velocity, the speed in a direction, changes with time. The slope is basically the acceleration of the object or car, but the area of this little triangle here is basically what we call the integral in math, but you don't need to know that for physics. That area is actually the position or the change in position, so the displacement. So this activity here is a little bit badly phrased, but if you were to sketch a graph of your journey to school today, you could first mark your position relative to your starting point. So the distance from your house to wherever you are currently, and that could be a point on a position time graph. And then you could connect those two lines, find the gradient to get the velocity. And if you found the area under that velocity time graph, you'd actually end up once again with the position. But if you found the gradient of that velocity time graph, you'd actually end up with acceleration as shown here. So yeah, that's basically all you need to know about these graphs. So these graphs are basically modeled by these sort of equations called equations of motion. And there's 4 of them. This is what they look like. You don't need to memorize these, they're in your data booklet. So the first one just says that final velocity is equal to initial velocity plus acceleration times time. The second one says that displacement is equal to initial velocity times time plus a half times acceleration times time squared. This is usually the most used on exams, so be familiar with this one. The third one is quite obvious. It's just a statement saying that displacement is average velocity times time. And the fourth one is a little bit trickier and again pops up a lot more frequently on exams. So let's just make a quick check. John travels at velocity 2 meters per second. He travels for 2 seconds. How far does he travel? So I'd like you to try this really quick and then I'll walk you through it. Have you done it? All right. So we know that his initial velocity is 2 meters per second. He travels for 2 seconds. How far does he travel? Okay, so we know that u is 2 and t is 2. So we know that we have u and t. We're looking for s, and we can assume that if there's no acceleration given or it says constant acceleration, that the acceleration is equal to 0. If it says no acceleration or if it's not given, we can assume there is no acceleration and that it's uniform motion. So we have this equation where a is 0, u is 2, and t is 2. So s is equal to 2 times 2, which is 4 meters. So now let's look briefly at free fall and gravity. This is something that becomes a lot more important in 8.2, but we can look at it briefly here. So free fall is the motion under the influence of gravity and gravity only. That means if I drop an apple from a balcony, it's going to fall down, and that's because of gravity. So we can assume that things like air resistance is quite negligible. So the acceleration due to gravity is 9.8 meters per second squared, and the terminal velocity is the velocity reached when the maximum velocity reached when the air resistance force equals the gravitational force, so when an object is in free fall. Now, air resistance is basically a force that opposes motion of an object falling through the air. This is not something you'll need to know right now. It becomes a lot more important in A.2 when we're calculating drag. So an IA idea from this topic is just dropping different objects and observing their motion. So this is projectile motion. I had AI generate this little pic for me here because it's a lot less violent than what you'd think a projectile is. So please ignore the weird labelings. So yeah, projectile motion, as it sounds, is literally just shooting a projectile. It's two-dimensional motion where an object is under the influence of gravity. It's not free fall because there's other influences, but gravity plays a major role. So horizontal motion, so that means this component right here, the horizontal movement, is basically just the constant velocity, neglecting, of course, the air resistance. That means that this bullet here, or whatever it is, always travels at the same horizontal speed when we solve a problem. Of course, this is not true in real life because there is drag that slows this down and eventually it comes to a stop, because otherwise if you shot a gun in, say, I don't know, Sweden, it would go round the circumference of the earth and eventually come back. So that's of course not possible because of air resistance. It would eventually fall, right? So vertical motion is the part of motion that's affected by gravity. As you can see, this really badly drawn gravity arrow right here. So vertical acceleration keeps changing and it's zero at the top. That's something you'll need to memorize. The vertical velocity is zero at the top and acceleration is always g. So yeah. So think about a video game. Think about how angles and force are used in something like Angry Birds. We've all played Angry Birds, right? So this little game where you shoot little birds from a sort of, what do you call it, a catapult, a trebuchet, so that they go and hit those nasty little pigs. Yeah, that's projectile motion, basically. So now that we've looked at projectile motion, this is basically two-dimensional motion. That just means we combine horizontal and vertical components. So the horizontal and vertical motion is independent of each other. So imagine a soccer ball being kicked, right? A football. So the horizontal motion of that is constant velocity if we ignore air resistance, but the vertical motion, the football always accelerates due to gravity, right? So it either increases in velocity or it decreases in velocity because of the influence of gravity. So this is relative motion. This is not really that important right now. It gets a lot more important in 8.5, but it's basically the motion relative to a person who's at a reference point, right? You can think of it just like this. If I'm driving a car and there's a car coming in the opposite direction to me, that car looks a lot faster than it actually is. But if it's going in the same direction as me, then you think that it's going a lot slower. You might have noticed this on the roads. If you're driving and there's another car tries to overtake you, that car looks a lot slower. So that's basically relative motion. That's all you need to know for 8.1. We'll get back to it in a lot more detail in A5. So what are the applications of kinematics? Because this stuff seems kind of boring. I hate it already, is probably what you're thinking, right? Well, there's a few applications. The first thing is engineering, right? So kinematics is really important for designing safe and efficient vehicles. It's really important for making sure that we can actually drive in our cars. It's also really important for sports science, right? Think of an athlete shooting a shot put. So they'd have to know at what angles to shoot it at, how to shoot it, why to shoot it, all of that stuff. So calculating the kinematics of that thing, of that shot put, can be really useful to that athlete. There's many other explorations, like many other places in which we could use kinematics, like space explorations and so much more. So yeah, that's pretty much the applications. So here are some of the most common mistakes people make on exams. Number one is that heavier objects fall faster. So people think that if I have a 100 kilogram dumbbell and I don't know if those exist actually, a 100 kilogram barbell and a 10 kilogram dumbbell, and I drop them both from my 10th floor window. Please don't do that, by the way, you'll probably kill someone. But if I drop them both from my 10th floor window, people would probably say that that 100 kilogram barbell is going to fall faster. Why? Because it's heavier, and we think that heavier objects fall faster. Now, this is one of the common traps the IB uses to try and weed people out who are not so solid on theory. In reality, we assume that all the objects fall at the same rate due to gravity. So it's like saying a rock, which weighs a kilogram, and a grain of rice, which weighs 10 gram, which weighs like a gram at most, fall at the same rate, right? The dumbbell might fall faster because it's bigger, so it might touch the ground first, but the rate at which it falls is identical. The second one is that constant velocity means no forces are acting. This is probably the biggest misconception you can make, and forces can be balanced, which result in a constant velocity. This is Newton's first law, which we'll look at in the next episode. However, this is something to keep in mind. If it says constant velocity, it doesn't mean that there's no force, it just means the forces are equal. So, let's try a problem here now. So, the question says a projectile is launched with velocity u at an angle theta. It reaches a height s. What is the time taken for the projectile to reach maximum height? Well, here's a question where I can show you the first of my tips that got me a 45. That is, the question asks for maximum height, so we use elimination. We know that the vertical component, anything to do with the vertical component, has to have sine theta in it, because the vertical component of a vector is u sine theta. So we look for something that has sine theta. Does option A have it? No, that's cos theta. What about option B? No, that doesn't have any theta. Option C? Well, that's cos. That leaves us with option D, which is also the right answer. So this is the first of my tips and tricks. I'll be teaching you many more along the way, so make sure to look out for the rest of the videos. Thanks for watching!